Thanks for joining us here on day 3 on the developer track. Next up, we've got a wonderful session by Mr. Christoph Runde, General Manager at Virtual Dimension Center. Mr. Runde has more than 20 years of industry experience and is one of the pioneers in the field of professional systems and applications of virtual reality and augmented reality. So let's give it up for our next speaker.
Yeah, thank you very much for the kind introduction. I hope we can see my slides soon. Okay, yes, thank you. So what I want to present to you, thanks a lot for the invitation and sharing these ideas with you. What I want to show to you is some work that we did in the recent 12, 18 months about benchmarking of VAR components and setup of a VAR measurement lab. I'm heading a network of virtual reality companies and virtual reality industrial end users, research labs, and so on. So mainly we are an association. We are not a research lab. And so the work that we performed here is a little bit exotic for us. But it was simply a demand from our members. So members of the VDCs are companies that are using XR. And of course, the question is, okay, we need a headset, or we got this environment, which headset to take, which kind of tracking system to take, which augmented reality library to take. And we wanted to have some answers to such kind of questions. And I guess many of us, we know maybe people from YouTube, they put their smartphone camera into a headset and trying to make movies and saying, okay, well, this got a good image quality, or this has a good field of view, and this doesn't have. And but it's for us, it was simply too subjective, and we said, okay, let's really try to measure it out with some homebrewed methods. I mean, we are not able to really to afford very cheap testing equipment. We can buy something, but not the absolute top-class measurement equipment. But what can we do with our own means, with our own developments to find answers? And just to give you a first overview of the things that we tried out and we began to test, it's to find answers, for example, in the field of course, the headsets, about image sharpness, luminance, readability of writing, contrast, color range, then true colors, of course, field of view. It's, of course, interesting, the stereoscopic range, the refresh rate, the weight distribution of virtual reality headsets. Then we had a look onto tracking systems. Of course, what's interesting, precision, working range, latency, also for augmented reality. And until now, we just worked on market tracking. Collaborative XR, we wanted to have ideas about robustness towards problems in the network. So how do they deal with that? And for projection augmented reality, we're interested in coatings and what coating is the best to do a projection-based mapping for augmented reality onto 3D printings. So let's have a look on how we got through the singular fields here, and we simply start with virtual reality headsets and static image quality. That's the first domain of measurement that we went to. And what we simply did, we designed and printed out a number of human heads with camera insets so that you can put in different range of cameras. So we got high resolution cameras, wide angle cameras, and then very fast cameras with a high frame rate, and we put them into these plastic heads and then put the headsets onto these heads, of course. Then for some of our purposes, we need monitor calibration hardware. We took this Spider X Elite device to get the screen content into the headset. We used the virtual desktop software, and according to these devices, you got certain test software, the IMA Test Master in this case, where you've got certain programs, certain images, movies that are shown, and then it measures on the other side with this camera. And so that was simply the setup. So it's not rocket science. It's really having this head, having the cameras, having monitor calibration hardware. You get the software with it, and having, for example, these test images from ISO or this Snellen index here, where you can check for the readability of writing, for examples. And during my presentation here, I want to rather focus on the kind of test equipment that we build up here. And of course, we got a number of results. And I mean, we can go through the results, but this will definitely go beyond the time that I got here to present to you all. But all the results that you see here, they are freely available. You can download simply from our website. Yeah, the reports are in German language, but of course, I think we all can understand the graphs here and the comparisons and so on. When we have a look into the image sharpness, for example, we made analysis of image contrast, white luminance, black luminance, and so on, and we simply sorted in all the headsets that we could get at that point. And of course, we're enlarging our measurements now with new products that get on the market. So we want to continue this work and simply enlarge this database of comparisons that we got here. Also interesting, of course, for us, color range, color accuracy. Of course, it's important to, for example, for the designers, they want to have the true color. If you work at Ferrari, you want to have your Ferrari red and not the red of a home appliance manufacturer, for example. That's, of course, it's important. Or if you're doing virtual reality training scenarios and you got little displays, for example, in your aircraft cockpit, then you need to ensure that with a headset you got a good readability of writing, that you can simply read what is written there in your cockpit. So that's, of course, important, and with quite simple means we were able to find answers really to all these measurement tasks that we see here. Then dynamic image quality. We had two setups mainly. First, we simply had this 3D printed head again with a comparator circuit that we designed ourselves with an oscilloscope pulse generator. And then we tested out a good number of photoresistors and photodiodes to find out which suits best simply for the different types of display technologies that we can find inside the headsets. We tested it out, and then we tested for refresh rate with this setup, and the setup number 2, which we see here, that was mainly for finding answers to, is there ghosting, yes or not? And then we took a high-frequency USB camera into, once again, a 3D printed head. And there are software for ghosting tests for monitors that you can also use in this case. Open Broadcaster software, Kinovea software that we were using here. And then we can simply, we could find out, okay, what's the measured frequency, what is the manufacturer information. So that was something that really interested us. And I can already say, and for this kind of measurement, the frequencies measured that were really quite precise to what the manufacturers said. So that was really very similar. And also for ghosting, it was interesting for us to see, is ghosting still a topic or not? And we saw, no, it's really no longer a topic. So we couldn't really find ghosting effects here. Then field of view. Of course, field of view is interesting to many XR applications. Once again, surely flight and driving simulators where you need a peripheral view. You need to have a huge field of view. So it's of importance. And what we simply took here, it's wide-angle USB cameras into a 3D printed head. And to calibrate the cameras, we took this half sphere here with a scale on the degrees here. So we took a photo inside, and then you could exactly see this is 90 degrees, 110, 30, 20, and 180, and 190 degrees. And then we made an overlay of this photo that we took here with a virtual reality scene that we took with the cameras here. And then we could simply see, okay, what is really the physical field of view when you are with your head, with your eye just in front of the display of this virtual reality headset. And there, in contrast to the refresh rate, there were some significant deviations from what we could see from what the manufacturer said and what we measured in the headsets. And some deviations were small, some differences were rather large. And yeah, the results of our measurements you can see here. So we measured, oh, sorry, let's get back. The binocular diagonal field of view degrees comparison with the manufacturer specification with original padding. Of course, the padding is, of course, of importance. If you have a huge padding, it enlarges the distance of your eyes to the display, so field of view becomes smaller. So padding is, of course, of influence. Then where the binocular horizontal field of view in degrees, monocular we measured here the right eye, vertical field of view in degrees, what we measured. Then the stereoscopic area, that's of course also interesting. Is it, do I have a really big field of view, but a small stereoscopic range? Could be satisfying, it depends on the application, but for some applications, if you've got, for example, manual assembly in a close range, then you need to have a good stereoscopic area just in front of you. And that, of course, we could measure with its 2 cameras and overlaying these images. And then we also had a look onto the influence of the face covers, of the paddings, if you use original ones or use more comfort ones. And yeah. Then next topic we measured out was weight distribution. I mean, it's simple, it's primitive if you want so, but it's quite hard to find outcomes if you look out and oops. And sorry, yeah. Oops, it moves from just like that. Can we get back? Yeah. Yeah, stop. So there we are. Okay, weight distribution. It's hard to find, oops, something seems not to work with the device here. Yeah, okay, thank you. Weight distribution, it's hard to find public findings really on that. You can get, of course, the measurements of the weight, or the manufacturer's statements on the weight. And we simply took now the styrofoam head mounted on a cross, which is resting on 4 scales. And then we can, of course, calculate the torque and inertia. And that's, of course, interesting because it surely makes a huge difference if the weight is here, or it's distributed also to the neck. And so what we have here, it's the center of gravity of the VR headset. So here it's 0 mainly, and the farther it's in Z-axis, and the farther the center of gravity is away from your head. And of course, on the one hand side, you've got a torque on your neck when you got a weight somewhere over here. And of course, the second effect is also the inertia. I mean, if you concentrate all the weight to the center of rotation, the up center of rotation, it's easier to turn your head. And that's, of course, also of interest. And here you can see weight and torque. And some manufacturers really succeed to have a good distribution of weight so that even if it's a heavy headset, the torque is relatively small and the inertia is relatively small. Then VR tracking range and precision, we took a robot, and it's a sub-millimeter precision robot with 5 axes that we got here, this U-Farm X-Arm 5-axis light. And we printed out the fixations for the 3D controllers. So you can see here moving. And the headset we fixed at the ceiling so that the robot can move beneath the VR headset. And so we can measure different layers here, and some of the results that you can see here. Of course, what's interesting is working range. It's a precision of the tracking. And what you can see, for example, here, if you get to measurement layer 1, that some of the headsets, like the Quest 1 here, doesn't really track when you get somewhere here behind you. And but some of the headsets, like the Vive Pro or the Rift S, they are much better in this field. Or here you see some information about the precision. It should be an ideal circle that we see here, and in many cases it's simply not. Of course, we know there's optical tracking, and if it's no longer inside, then the 9DAF IMUs take over, and some of them are good and some are less good. We have to confine. Then augmented reality tracking and precision. How did we do this? We had this mechanical structure here where we put in a tablet PC and redirected it towards this marker here, and really with a crosshair put it to 0 with a camera image on the tablet PC, and then we can see, okay, the x-axis and the y-axis need to be 0 in that moment, and the distance, the z-axis, we can simply get with this distometer here. And so this is what we expect as outcome, and then we look on the other hand, what is the augmented reality library saying where the marker is. Is it really at 0 distance, or is it at another point? And then we also made dynamic measurements where we put the tablet PC again into this robot here, and we tested it with different light conditions, so we have a lux meter here and see if it really works, also if it's quite dark or quite light. So this is some of the outcomes. We got many, many more of these graphs, of course. In the end, yeah, we had these 3 libraries, AR Core, AR Kit, and Vuforia, and yeah, with some strong points of the other one library and the other library, and yeah, what you can see here, mainly, yeah, AR Core was the weakest in nearly all the fields. Just in the speed, it was relatively okay, and yeah, working range, it's also quite different. So this is Vuforia up to 3 meters with a 10 centimeter times 10 centimeter marker, then AR Kit and AR Core in the end. Then distributed collaborative VR, we tested with a network emulator, this one, to find out at what point does it become critical if you got packet loss or low bandwidth or huge latency in your network. And I mean, what is really important if you got dynamic avatars? You got users with controllers that are moving or that are talking, then you need good bandwidth. I mean, if you simply got keyframe animation, it's just a single command. It's sent to all the other hosts, and they are performing this animation. But if you got this, what we said, a talk and wave scenario, we also made it with a robot, so we got a normed waving, and this is transmitted to another scene, at another position, and then we can see if we attach both with a timestamp, what's the difference if we have different network settings here. And yeah, there are some results here, and we just begun with this work and also tested different number of users. At what point of users does it become critical? And we saw, okay, the data transfer rate raises up until a certain number, until 6 users, and then it remains the same. That was quite interesting to see. And yeah, we're continuing the work on this here. Until now, we just had a look onto one solution here. And I think this should be last of what I have to present here, the coatings for AR projection mapping. Idea here was, okay, we want to have hybrid prototypes that you can both touch, take in your hands, that are tangible. On the other side, we want to take the advantages of digital illumination of computer graphics and interactively, and having dynamic content. So the idea is to use 3D prints and to code them and then project digital graphics on it. And the question is, of course, what's the best color to use if you want to have perfect white and perfect black at the same time, of course. And therefore, we had several coatings here with screen color that we mixed with blackeners and so on. And then we had a projection on it, took photographs at the same time, and then calculated contrast and so on. And in the end, it depends largely on the projector, what is the maximum contrast. If you put really high lumens on the projector, until a level where it does not, or still does not, level up the black light. And this is usually the limit. So in the end, you should make your color, let's get back, your color as black as possible, make the contrast as huge as possible, until the limit where the projector keeps the black as black and not makes white whiter and black also whiter at the same time. And then you get really nice models like we see here. This is this concept car from Mercedes, the Avatar. So these are some plans for the future, some actual activities. We had first looks on 180, 360 degree cameras that we tested out. We started first test now with markerless tracking, object tracking. Of course, it's much more interesting than marker-based tracking. We had a first look onto heat development. And yeah, I mean, the headsets, they get warm, but we could not see any device disasters like we had a few years ago with the Google Glass One that gets up to 60, 65 degrees centigrade and then burns your ear. So we could not see this anymore, but they get warm. But we are still working on this. And smart glasses, that's of course, it's much more challenging than VR headsets because it depends largely on what is behind the smart glass, what is the background if you talk about the image quality here. Field of view is easy, of course, but image quality, that's really hard stuff to do here. Projection screens could, of course, be interesting, and of course also LED panels that I really see that's really something we will see more often in the future, and perhaps also replacing in many applications projection-based virtual reality systems. So that's it so far. I got 1 second left. Thank you very much for your attention. All the reports in detail can be downloaded free here on the site. And I would love if any one of you says, okay, we're doing similar tests to exchange our knowledge, our know-how, our approaches of doing this. All we do here, it's freely available. We give it out to the community. We want that the best systems succeed in the market, and that's what we are looking for. Thank you very much.
Wonderful. Thank you, Christoph and VDC. If we've got any questions, you can go ahead and find your way to the mic in the middle of the room.
So everything is clear, everyone is confused?
Hi, Christoph, thanks so much. I was wondering, have you contemplated doing any wear testing? How long the equipment can be used over and over again? Is that something that perhaps you're considering?
Yeah, could be interesting. I mean, we didn't test it, so robustness test yeah, I mean, you need other equipment to do this, for example, to use it for mechanics or for projectors. It's of course interesting that they lose their luminosity over time. Yeah, we don't have equipment for this, but it's interesting. I mean, we described really in detail how we did all the tests and the test procedures, and sometimes we've written software to do this. That means we are able to do the same test. I mean, we need to do this, the same test a year again, after 2 years again, and then we can compare results. That could be interesting, yeah.
Hi, I may have missed the question, but did you actually go through and test different environmental conditions, indoor, outdoors, different lighting, rain, things like that?
Outdoors, not really. I mean, the only setting where we took into consideration the lighting was the AR market tracking, where we got the lux meter inside and tested over there. All the rest, let me check. No, we had in-house testing also for the VR tracking systems. I mean, that could be absolutely interesting topic, what is working outside in sunshine and so on, and didn't get mixed. But until now, we didn't do this. But it's absolutely a point. I agree.
My question is that, this is Murat from Quantum 3D. We buy most of the headsets and then we try for our own applications, but we don't do tests like that. So you buy from the market or you buy from the company, and then what is your funding? How do you make money out of it?
Yeah. Yeah. We are a network, an association, so we got memberships, and we also have, we are participating in public funded projects, so from European Commission, German government, or regional government. We buy all the stuff that we see here, so we do not get those devices for free, maybe implicating that we are doing a favor. No, we're buying all the devices here. And why do we do this? We got at about 90 members in our association, so companies that are using VR AR, and they want us to test, and they want us to purchase devices also for them to test. So we're buying it, and we are giving it to our members, and they can test the latest HMD or the latest tracking systems, and they do this for free from us. And that's our motivation.
Do you contact the manufacturers that, oh, this is the problem, you fix it or something? How do you?
Yeah, sometimes the manufacturers contact us afterwards. So we got some telephone calls afterwards, and of course we are in contact with HTC or with HP and so on, and they see the results that we have here. They find it interesting, and I hope they take this as a motivation to improve maybe on the one or other edge, and that would be really something I would appreciate very much, of course, definitely.
Okay.
That's
Thank
one
you.
of the motivations also.
Wonderful. Thank you very much, Christoph. Let's give him a final round of applause here.